Now, the topic is time cost optimization. That is nothing but a project caching time cost optimization algorithm. See, first step, what you have to do, find the normal critical path and identify the critical activities. Just to identify the critical activities, then you find the cost slopes. Cost slopes for all the activities, not only critical, all activities. Then that is by using the formula crash cost minus normal cost by normal time minus crash time. Then you rank the activities in ascending order of the cost slopes. So just based on the cost slopes. Crash the activities in critical path as per the ranking. Activity having lower cost slope would be crashed first to the maximum extent possible. Calculate the new direct cost by cumulative adding the cost or crashing to the normal cost. Parallel crashing. As the critical path duration is reduced by crashing in step 3, other paths also become critical. So we get parallel critical paths. This means that project's duration can be reduced duly by simultaneous crashing of activities in the parallel critical paths. Next, to total cost. Crashing as per step 3 and 4. One reaches a point when further crashing is either not possible or does not result in the reduction of the crashing of the project's duration. Now I'll explain this algorithm. This is time projects crashing by taking one illustration. I'll explain now. Now, from the data given below the table, draw the network, crash the project to its minimum length at the lowest possible direct cost, assuming there is no direct or opportunity cost. This table is given, just jobs are given normal time, normal cost, crash time, crash cost. Like this will be given project cost. Projects related data is given. He is asking us to crash the project crashing is asking. Solution, first you draw the network diagram by using the data given above. That is 1 to 2 is network, then 1 to 3 is like this, 2 to 4 is like this, and 2 to 5 is like this, and 3 to 4 is like this, 4 to 5 is this. Just you draw the network diagram like this. Then you find out the forward pass by using the forward pass method and backward pass method. No need to in detail, no need to write. Just directly we can calculate that is TE1, TL1 like that. Earliest times and the latest times we have to calculate. Just instead of using TE, I use just E1 and L1, E2, L2, E3, L3 like that I've used. So you know forward pass method and the backward pass method. By using the forward pass method, we'll get the earliest times. By using the backward pass method, we'll get the latest available times. So directly we can do, no need to write, those are all directly. First we keep it 0, E1 here, 0 plus 8 is 8 here, 0 plus 3, 0 plus 4 is 4. Then go to fourth activity. Here this is a fourth, E4. 4 means what? E3 plus 5. That is 4 plus 5 is 9. Here 9 is not there. Why? Because 8 plus 2 is maximum of these two should be taken. That is why I've taken 10 here. Then 5, you go to 5. This is also merged activity. Maximum of these two you have to take. Here 10 plus 3 is 13, but 8 plus 10 is 18. This is a maximum. Now backward pass method. 18 minus 10 is 8. 18 minus 3 is 15. So like this you calculate the E1, L1 values. Okay, we found. Now wherever E and L values are same, that is called the critical path we know. These are the critical activities 1, 2 and 3. The path is critical path. 1 to 2, 2 to 5 is a critical path. First step after drawing this, you have to draw the, first you write what is the critical path 1 to 5. 1 to 5. Project's duration is nothing but total time taken, that is 18 days. Total cost is given. First you have to calculate what is the total cost. By using the normal cost, we'll calculate the total cost. That is the sum of this normal cost 100 plus 150 plus 50 plus 100 plus 100 plus 80, that is equal to 580 rupees we got here. Then after finding this, then next step what you have to do, you have to calculate the cost to slopes by using crash cost minus normal cost by normal time minus crash time. So for all the activities, 1, 2, 3, 4, 5, all activities, 1 to 2, 1 to 3, 2 to 4, 2 to 5, 3 to 4, 4 to 5, these are all the activities you calculate the cost to slopes. So you'll get these values. So in this least value, we'll check up later. Next, what you have to do, which activity, this is a critical path. So which activity must be crashed? So that one we have to find out. That is called iteration 1. First iteration will do. Critical activities, we know what are the critical activities? 1 to 2 and 2 to 5. Those are the critical activity. Critical path 1 to 5. The critical activity having least cost to slope is 1 to 5. Only critical activities I am considering for the slopes. So 1 to 2, 2 to 5. 1 to 2, 2 to 5, which is the least, 60 or 50. So 50 rupees is the least one. So least cost to slope is 1 to 2. So next, what are the how many units must be reduced, that is crashed? That is the next question arises. You find out the various paths. That is how we can go to 5. So 1, 2, 5. This is one way. Another way is 1, 2, 4, 5. Another way. Next way, that is 1, 2, 3, 4, 5. These are the various paths I have written here. What is the longest path according to this? 18, 30, and 12. If you go to like that. So since the next longest path has duration 13, this is the next longest up after 18, is 5 less than the critical path. So the difference is 5. So we can we can crash maximum 5 units. That is 5 days. Maximum possible extent is 5. But how many units possible, we have to check later. So here possibility is 5. But here normal time minus crash time is according to problem here we can go to maximum. We can crash by only 2 units. So 2 units are possible here. So now I am crashing the activity 1 to 2 by 2 units. So now previous diagram as it is you copy down. Now you have to calculate again activities, because here we have changed. This is 6. Earlier 8 was there, now it is 6. Now again you find out what are the even L1 values by taking this. So we crashed 2 units here. Instead of 8, we reduced to 2. That means now 6. Now you find out all even L1 values. Again changes these are all. Now we got the total duration is 16 days time. Now after caching. What are the critical activities? 1 to 2 and 2 to 5. Same we got. Critical time. Critical path is 1 to 5. Critical activities we got. Next. Next one. So your total cost is how much according to this? Normal direct cost plus direct cost due to crashing plus indirect cost. So how many units we reduced? 2. 2 units. What is the cost slope? The number of days crashed is 2. The rate of cost slope is 50. Just now we calculated 50. Cost slope 50 rupees. That means 100. So already 580 earlier. Now 580 plus 100. That is 680. Now can we reduce? Can we crash further? We have to check. Now, second iteration. Critical activities, we found 1 to 2, 2 to 5. Critical path 1 to 5. Now, according to this, we got the 16, 11, and 12. 16, this is one way. This is another way of going. This is another way of going to 5. So this is, we got 16, 11, and 12. Next to longest is 12. So we can crash maximum to the extent of 4 units, 4 days. But how many units possible, we have to check, because the critical activities are 1 to 2, 2 to 5. From these two, what are the possibilities, you have to check. So now activity 2 to 5 can be crashed for maximum extent of 4 units. So 2 to 5, the normal crash time is 5. So, but it is possible to crash only 4 units as it is least. Now 4 units I am crashing. Which activity? 2 to 5, this one. Earlier 10 was there, you copy down the previous network diagram here. Earlier activities are all same, only you have to change it to 2 to 5. Earlier 10 was there, now we are reducing it to 6 because 4 units we are reducing. Again, you have to calculate the E1, L1 values. So we got here a total duration is 12 days. Okay. Now how many 4 units we are reduced? What is the total cost? Earlier already 500 plus 2 into 50 plus first iteration, and the second iteration is 4 into 60 because cost to slope is 60. Now total is 920 rupees. Now we got, see, once we got this, again some more critical paths we got here. See, another critical path we got because this is 0, 0, 4, 4, 9, 9 and 12, 12 and like this. So simultaneously we have to, whenever you get two critical paths, simultaneously we have to reduce. 3 critical iteration 3 critical paths 1 to 5. Since there are two critical paths, crashing has to be done simultaneously for both the paths. Simultaneously we have to done the crashing. Now what are the common activities in both paths? There is no common activity. You see, one is 1 to 2 5, another one is 1 3 4 5. There is no common activity. Then 1 to 2 is 0 because maximum we have reduced here. 2 to 5 is only 1 unit we can do. 1 to 3, 2 units we can do here. So 3 to 4 according to normal and crashing times. So 4 to 5, 2 units you can do. So the least cost slope in this is 4, 5 activity, this activity. So that how many units? So maximum units you can do is only 1 unit. So that is 1. 2 to 5 by 1 unit as well as 4 to 5 by 1 unit. These two simultaneously we have to solve. So now again you have to copy down. Now we have reduced, we crashed one activity, that is earlier the time was 6, now it is reduced by 1, that is now 5. Earlier it was 3 days, now it is 2. Now critical paths, what are the various critical paths we got here? So total cost according to this is 990. Okay. So are there any critical activities? There is no further. We cannot we cannot further reduce because simultaneously we got maximum we did. So again we got this one 0, 0, 4, 4, 9, 9, 11 and 6, 6. The total cost is 582 into 50 rupees, 5 into 60, 1 into this is 10. Okay, is 990 rupees. So this is a solution for this.